Alright, so in this video we go over section 6.2, in this case part B, the second part of adding and subtracting rational expressions, but in this case with different denominator or with unlike denominator. So something to recall, it would be a good idea to do this with numbers first and then do it with rational expressions. So when we added 1/3 plus 1/6, well, in this case we cannot add 1 plus 1 and 3 plus 6 to do 1 plus 1 equals 2 and 3 plus 6 equals 9, getting to 9. So that's not the correct way to solve this problem. In this case, well, we need to find the least common denominator. That is a number that divides both number 6 and number 3 evenly. If we do the actual approach to this is 1/3. This one leaves the same. I'm going to leave space for missing factors. I'm going to factor out the 6 as 2 times 3. Alright. So in this case, if we look for the missing factors, well, the missing factor would be the number 2 for the first fraction. That's going to leave us with 1 times 2 to be a 2 and 3 times 2, which equals to 6. And this I'm going to go back to rewrite it as 1/6. Well, in this case, we added the missing factors by looking at the LCD in order to convert these to fractions with equivalent fractions that have the same denominator as opposed to fractions that didn't have in the first place. So 2 plus 1 equals to 3 over 6, which reduces to, in this case, 1/2. So we're going to do exactly the same process but with algebraic expressions. So the process or the steps to do that is, well, number 1, find the LCD, which we already did in the previous section, and then step number 2, rewrite each rational expression as an equivalent rational expression whose denominator is the LCD. Okay, so which is also what we did in the previous video. And then for step 3 is to add or subtract and write the sum or difference over the common denominator and simplify whenever possible. So let's look at this couple of examples. So we have 2x, 1 over 2x plus 3 over x squared. Let's find the LCD first. So the LCD will be, well, notice we have factors of 2 and factors of x. But if you look at the powers of the factors of x, we have x to the first power and x to the second power. So the highest power wins. So what are we going to do in this case? We are going to write these fractions in an equivalent form that we have this common denominator. So I'm going to do the following. 1 over 2x. I'm going to leave space for missing factors. And 3 over x squared. And I'm going to have some space for missing factors. Now, notice we have 2x. What do we need to have a 2x squared? Well, in this case, we need to multiply numerator by x and denominator by x. And for the second fraction, we have an x squared. We need the factor of 2, so it means we need to multiply and divide by 2. Let's multiply across for each fraction. So I'm going to take care of the first multiplication, 1 times x and 2x times x. That's going to give us 1 times x equals to x, and the denominator 2x times x, that's 2x squared. Do you see that we have just the LCD now? Plus 3 times 2, which equals to 6, and x squared times 2, that's going to give us 2x squared. And notice now we have the two fractions with the same denominator. So now we can combine the two fractions together with the LCD in the denominator. Now write the sum or difference over the common denominator. Okay? Over the common denominator. So the sum x plus 6 over the common denominator. And in this case, well, we cannot factor anything from x plus 6, so final answer. We're done over here. Okay, let's observe letter B. But before doing letter B, let me go up here and give you another example. What about something like, I don't know, let me make something up over here. I'm going to add let me do 2/3 plus 3/5. Okay, so in this case I cannot add 2 plus 3 and 3 plus 5 to get 5/8. That's not the way to do it. In this case, well, we have two different numbers that do not have common factors, in fact. So in this case, we need to multiply by 5, and this one we need to multiply by 3. Okay, that's going to give us the LCD. In this case, the LCD is the product of the two, which is 15. So 2 times 5, which is 10, 3 times 5, which is 15, plus 3 times 3, which is 9, and 5 times 3, which is 15. And now we can combine these two together. Big bar, do the operation, 10 plus 9, divide by 15. So that's going to give us 19 over 15. Final answer. So in this case, something similar will be done for these two, because x plus 2 and x minus 7, they are both different factors. So the LCD will be the product of the two. Alright, so we need to transform these two fractions into those that have this denominator. Okay, how are we going to do that? Well, let's rewrite this. 4 over x plus 2, I'm going to leave space for missing factors, minus 5 divided by x minus 7, and some space for missing factors. Alright, so for the first fraction we have the x plus 2, we are missing the x minus 7. For the second fraction, we have the x minus 7. We are missing the x plus 2. Alright, so now we're going to multiply this across. 4 times, or I would spend in this case one step to write the whole thing in a huge bar, and the LCD in the denominator, x plus 2 times x minus 7. Okay. And in the numerator, I'm going to have 4 times x minus 7 minus 5 times x plus 2. So then from here, what we'll be doing next? Well, that is correct. You thought right. Distribute and distribute. Distribute and distribute. Notice in this case, this negative sign will affect both the x and the 2. Okay? So 4 times x, that's a 4x. 4 times negative 7, that's a negative 28. Minus 5 times x. And negative 5 times negative 2, that's a negative 10. And divide by the LCD. So we're going to combine like terms. 4x minus 5x, that's going to give us negative x. And negative 28 minus 10, that's going to give us a negative 38. Alright? and that divided by x plus 2 times x minus 7. Okay, so what are we going to do here? Well, there's only one thing that we may do to simplify this, because I mean we cannot factor out anything in the numerator other than the negative sign. So this will be negative x plus 38 divided by x plus 2 x minus 7, and this will be our final answer. Okay, let's move to the next page, see what's in there. All right, we have 1 over x squared minus 1 plus 3 over x plus 1. So in this case, this is our first example in which we are going to find the LCD, in this case by factoring the denominator. So notice we have x squared minus 1, which factors as x plus 1 times x minus 1. 1 over that. However, I'm going to leave some space here for missing factors, if any, and then 3 over x plus 1, and some space for missing factors, if any. Alright, so let's find the LCD. So the LCD will be the product of the distinct factors in this case. One of them is x plus 1, and the other is x minus 1. Alright, well, notice the first fraction already has the full LCD, so we don't need to add any missing factors. However, it is not the case for the second fraction, because that only has as the denominator the quantity or the factor of x plus 1. So we need to add one missing factor, x minus 1. Don't forget to add actually parentheses here. It's going to matter. So now that we have the two fractions with the same denominator, we can put them together. Okay, so x plus 1 times x minus 1. And in the numerator, we're going to have only the 1 plus 3 times the parentheses. I know what you might be thinking. Can we do the distribution? Yes. I mean, if you feel comfortable with doing two steps in the same one step, that's fine. However, that might be some room for mistakes, so I would recommend you to first leave it indicated, and then on the next step distribute. So this will be 1 plus 3 times x, which is 3x, and 3 times negative 1, which is negative 3. X plus 1, x minus 1. And all we do here in this case is simply combine like terms. So 3x, there's nothing else to combine with, and 1 minus 3, which is negative 2. And then divide that by x plus 1 times x minus 1. And in this case, this is a final answer. And that's because in this case, nothing divides out. If we try to factor anything in the numerator, 3x minus 2, nothing goes out as a GCF, so we can divide this out. Okay? Let's look at another example. Letter D. So for letter D, well, in the denominators we have a couple of trinomials with leading coefficients equal to 1. So what is that going to be in this case of factoring? Well, double bubble for each. Factors of 2 that add up to negative 3, x and x. Well, in this case, negative 2 and negative 1, because negative 2 times negative 1 equals positive 2, and negative 2 minus 1 equals negative 3. and I'm going to leave space for missing factors, and I'm going to add the plus. Actually, not a plus sign, it's only a negative sign. Okay, so minus sign, and I'm going to factor this. Factors of -2 that add up to -1. Double bubble it. Factors, those are going to be -2 and +1. And that's under 1. Okay. So let's find the LCD. The LCD will be the product of the distinct factors that appear in all denominators. In this case, x minus 2, x minus 1, and x minus 2. I already wrote it. I don't need to write it again. We only write it once, and x plus 1. Okay, so that's going to be our LCD. Now, let's look at the denominator of each fraction and compare to find out which factor is missing from the LCD. So we have x minus 2 and x minus 1. We're missing x plus 1. Then we have x minus 2 and x plus 1. We're missing x minus 1. Alright, so now that we have both fractions with the same denominator, all we do is write a big division symbol, write the LCD below, and 1 times x plus 1, which is simply x plus 1. No need to keep the parentheses. However, we need to keep parentheses for the second numerator because we have a negative sign in the front, and that's going to affect both terms in here. Alright, so what are we going to do in this case? Well, distribute the negative sign. Okay, and in this case, well, x plus 1 minus x, and then negative times a negative is positive 1. X minus 2, x minus 1, x plus 1. Cancel, cancel. 1 plus 1 equals 2. Over the LCD. X minus 2 times x minus 1 times x plus 1. Final answer. Let's do one more example. So x squared minus 64. Alright, x squared minus 64, that's a difference of squares that factors as, well, actually let me go here, otherwise it's going to overlap over there. So this will be x plus 8 times x minus 8. Minus the factorization of this trinomial whose leading coefficient is 1, double bubble, factors of 64 that add up to 16, that's a plus 8 and plus 8. Because in this case, well, 8 times 8 equals 64 and 8 plus 8 equals 16. Now notice that this factor is repeated. That's why I didn't leave space in between for missing factors, because we're not ready yet to find missing factors. So what we're going to do here is x plus 8 times x minus 8, and then plus, in this case I'm going to leave the space for missing factors. This will be, Well, x plus 8 times itself is the same x plus 8 quantity squared. Alright, now let's find the LCD. So the LCD will be the product of all the distinct factors. So x plus 8 and x plus 8. But notice this x plus 8 appears in two versions. One version to the first power and another version to the second power. We go with the highest power of each. The other factor is x minus 8. Okay. So that's the second factor. All right. So we have for the first fraction x plus 8 times x minus 8. But notice the x plus 8 has to be to the second power. That means we need one more power of that one. On the second fraction, we have the x plus 8 to the second power. We need the x minus 8. That's the missing factor in there. All right. So now that we have the same denominator, x plus 8 times x plus 8. All right. So if you prefer, I'm going to multiply this across. X times x plus 8. And in this case, I'm going to rewrite this as x plus 8 times itself. That's x plus 8 quantity squared times x minus 8. Plus 1 times x minus 8, that's simply x minus 8. And the denominator x plus 8 quantity squared times x minus 8. Alright, so now you observe these two fractions, they have the same denominator. So we are ready to combine them into a single fraction. That under, okay, x times x plus 8 plus x minus 8. So what are we going to have? X times x times 8. That's x squared plus 8x plus x minus 8. X plus 8 quantity squared times x minus 8. And be careful. You don't want to cancel this x minus 8 with that x minus 8, because this x minus 8 it's among the terms, but this x minus 8 is a factor. Those are not the same. What happens if we divide out terms? Well, kitty dies. So in this case, what are we going to do? Combine like terms. That is x squared plus 9x in this case. Wait, did I do plus? I believe I messed up a sign. This was supposed to be a negative sign. This was supposed to be a negative sign. Okay, and in this case, this negative this is a negative sign. So we distribute that negative over here and over there. So that's going to be a negative x and a positive 8. So in this case, we're going to have x squared plus 8x minus x, that's a 7x, and plus 8. And then divide that by x plus 8 quantity squared times x minus 8. Now in this case, we are essentially done with combining the fractions together. However, we may need to factor the numerator to see if we can divide out with any of the factors. However, if we try to use the double bubble method on x squared plus 7x plus 8, factors of 8 that add up to 7, it's impossible to do. So in this case, we can call it a day for that example. Alright, let's do one more. Let's look at the very last page. Alright, so now we have one with 3 fractions. So this is what we do. I'm going to rewrite the whole thing to leave space for missing factors. X minus 3 under 1 minus 2 over x plus 3. And I'm going to write the factor version of this. In this case, that is a difference of squares that factors as x plus 3 times x minus 3. LCD. The LCD will be the product of all the different factors, x plus 3 and x minus 3. So now it's time to compare each fraction. Check each fraction for missing factors. So here, x plus 3, x minus 3, if we observe the first fraction, it has the x minus 3 factor. We are missing the x plus 3. Okay. For the second fraction, we have already the x plus 3, x minus 3. And for the last fraction, notice we have the LCD. So in this case, we don't need to add any missing factor. So how are we going to deal with this one? Well, for 3 or 4 or more terms, we do the same. Big division bar, LCD, 1 times x plus 3, that's simply 1 times x plus 3, minus 2 times x minus 3 plus x. What are we going to do next? You guessed well. Distribute the 1. Well, that's not going to do anything interesting, but over here, be very careful. Because this negative 2 is going to multiply these two terms, but it's also going to change its signs. All right? So 1 times x, 1 times 3, that's simply x plus 3. Negative 2 times x, that's negative 2x. Negative 2 times negative 3, that's a plus 6. Finally, don't forget about this x. Whole thing divided by x plus 3 times x minus 3. Alright, let's keep moving with this one. Well, in this case, all we do is combine like terms. But notice how this x plus x equals to 2x minus 2x, that's 0x. And all we do is 3 plus 6, which equals to 9. And this is final answer. Alright. Let's do letter G. Letter G could be a little bit tricky, you know? Because if you observe the denominators at first glance, they look different. So do we really need to find an LCD for this one? Well, not in this case, because we have the same A and B, but we have them in different order with the same sign. So in this case, we are going to do something that we already did. So x minus 3, 13 over that, plus x minus 3, provided we factor out a negative. All right? And then again, adding a negative is the same as subtracting. and ultimately we have two fractions with the same denominator. All we do is 13 minus 4, which equals 9. Final answer. And the last example for this, well, this one is going to look a little bit interesting, because now we are going to have two denominators that are trinomials with leading coefficients different than 1. So in this case, what are we going to do with these two? For these two, use the diamond method. Alright, so I'm going to do the first one. 2x times, so for the first one, I'm going to have 2x squared minus 9x minus 5. So I'm going to do this diamond method here. So 2 times negative 5, that's a negative 10, and negative 9 goes below. So factors of negative 10 that add up to negative 9, in this case I'm going to have negative 10 and 1. So that means I'm going to split this into 2x squared minus 10x plus x minus 5. And then I'm going to factor this by grouping. That's going to be 2x times x minus 5 plus x minus 5. Okay, that's 1 times that. GCF x minus 5 so that's the factoring of the first denominator. Let's do the second denominator. So that's going to be 6x squared minus x minus 2. Alright, so I'm going to multiply leading times constant. That's going to be negative 12 and negative 1. So factors of negative 12 that add up to negative 1, that will be negative 4 and 3. So we will decompose this negative x as negative 4x plus 3x. And then just bring down this negative 2. Alright. So this will be, okay, the GCF on the first group and the GCF on the second group. So 2x, 3x minus 2, and in this case simply 3x minus 2, but the only factor in common is the 1. New GCF, 3x minus 2 times 2x plus 1. Okay, so now I'm going to go back to the original problem and rewrite these denominators into their factor forms. That is 2x plus 1 times x minus 5. I'm going to leave space for missing factors. This trinomial becomes this one I have below, 3x minus 2 times 2x plus 1. Everything under x plus 3. Alright, we need to find the LCD for this one. I'm going to write it below. The LCD will be all the different factors that we see, in this case 2x plus 1, x minus 5, 3x minus 2, 2x plus 1. Well, I already wrote it here, so we need to write it only once. So that's our LCD. Okay, so I'm going to look for missing factors. 2x plus 1, x minus 5, 3x minus 2. So in this case, we're missing the factor of 3x minus 2. For the second fraction, we have 3x minus 2 and 2x plus 1. We're missing x minus 5. All right, let's move on. This one is still going to take a good minute. So this is what we have in here. I'm going to write a huge fraction with the LCD below. And then I'm gonna indicate these products. The product of these two plus the product of these two. All right. So what are we going to do next? Well, yes, you guessed the well, FOIL. Multiply those two first. 2x times 3x, that's going to give us 6x squared. And then 2x times negative 2, that's negative 4x. We're going to do the second part of the foiling, negative 1 times 3x, and negative 1 times negative 2. So negative 3x plus 2. And let's do the same over here, x times x times negative 5. Notice the plus sign here, no need to worry about changing any sign. So plus x squared minus 5x. 3 times x, 3 times negative 5. Everything divided by the LCD. 2x plus 1, x minus 5, 2x plus 1. Alright, so this is what we're going to do here. Let's combine like terms. So I'm going to combine the square terms. So this will be 6x squared plus x squared. That's a total of 7x squared. And then over here, negative 4x minus 3x minus 5x plus 3x. That's going to be, okay, negative 4 minus 3, that's negative 7. And then negative 7 minus 5, that's a negative 12. And finally, negative 12 plus 3, that's minus 9x. And finally, 2 minus 15, that's going to give us negative 13. The whole thing being divided by the LCD, 2x plus 1, x minus 5, 2x plus 1. That's final answer in this case. I know this is final answer because I already tried factoring this trinomial in the numerator. Well, let's see if we can do it just for fun. So 7 times negative 13, that's negative 91. And then bring down the middle coefficient. Well, are there any factors of negative 91 that add up to 9? Well, if we use a calculator, let's see. 91, I'm going to divide that by, well, it's not divisible by 2, it's not divisible by 3, either. Well, 91 divided is not divisible by 4. It's not divisible by 5, not divisible by 6 either. Over 7. Well, 13 and 7. That's one possibility. Or negative, but the thing here is negative 13 plus 7 is not negative 9. So in this case, it's not going to be possible to factor this polynomial. So this is a prime polynomial, and we're going to leave it like this. And this is the end of this video. This is the end of this section. I'll see you on the next one.